Hi, thanks for joining this session, guys.
Good morning, everyone.
Morning. So we're going to start with a brief history of PKI. It's pretty much the same, same infrastructure. We could argue it's also the same processes and potentially even the same people. And all of those people are trying to make it work. So effectively, there is nothing else that's likely to replace it anytime soon. So essentially, everybody is trying to wrap processes around it, make it work for modern applications and infrastructure. And this is really the sort of the basis of this sort of talk as to how we make it and bootstrap it and make it available and usable in the 21st century. So this is sort of how it looks. So the problem we've got today is there's lots of things now being built on existing PKI infrastructure. And it really does look a little bit like this. You sort of knock that PKI out from underneath and then everything stops working because effectively it's very centralized and everything connects back to that sort of centralized PKI service. As you can see, very, very centralized dependency on that one single point of failure.
One of the main reasons we think that this centralized hierarchy is not going to work anymore is actually this post-it note from the Snowden leaks in 2013. Inside the Snowden leaks of 2013, there was this post-it that showcased that the NSA had access to Google's internal networking. So even though all of the north-south traffic was secured and encrypted, so the end users had encrypted lines over the public internet, the communication between the different data centers, between Google, they were running their own fibers, was compromised by the NSA. So the NSA was able to listen into the Google data center kind of networking. And that's when Google decided to also internally encrypt all of their traffic. But then you are having an explosion of amount of certificates you require, and it becomes a lot.
Generating millions of certificates, what's the problem with existing sort of centralized PKI? So I think in reality, I talk to many customers about this and lots of platform teams and modern architecture teams within lots of our customers. And one of the sort of big considerations or concerns is the fact that they have this sort of dependency on external services. So if you think about building this sort of modern infrastructure using Kubernetes, microservices, containers, service meshes, and all of this modern sort of technology, there's lots of dependencies on sort of calling out to an external service to get a certificate. And if that stops working and that little PKI peg fails, all of those services stop working and sort of essentially everything comes tumbling down. The other issues are sort of network latency, just generally slowing things down, overloading the API. So if we're generating and putting requests through for millions or, and some of our customers are literally talking about modern technology stacks, requesting billions of certificates a year for some of these modern services, the single point of failure and overloading an API is a real problem and a real threat. And even worse, it's really difficult to sort of scale traditional PKI services. If you look at the sort of back-end CA technologies, they weren't really designed for this sort of modern workloads, modern use cases, and weren't really sort of built to scale up particularly. Yes, it's potentially doable, but it's a lot of work and it's quite difficult to manage. So sort of meanwhile, I've been doing some research as the sort of chief security officer within global tech and started to realize actually this problem's quite pervasive in terms of what's really happening out there in the world. In fact, the sort of concept of embedded CA in some of these technologies is sort of becoming more and more prevalent. And there's some examples of, literally lots of different technologies now that are starting to embed them. And the problem here is that obviously all of these CAs are pretty much disconnected, they're silos. So whilst you can stand these CAs up quickly and your developers can start using them really quickly, they're pretty isolated, they're unmanaged, and we sort of sometimes call them maybe rogue CAs. The fact that now, these, developers and platform engineers are standing up their own certificate authorities is a clear and present risk, I think, to many organizations.
And one of the other challenges as well is some of these things need to work together. For example, I see Istio on here and Spiffy kind of thing. So you want to establish trust between these kind of things, and by having these isolated CAs that are not communicating with each other, it's really hard to do that.
So this is what's sort of happening if you sort of put that into perspective now. So now we've got sort of the foundational corporate enterprise CA, and then these sort of silos of CA sort of popping up across different parts of the enterprise where developers are building their own solutions. And this is now how the sort of CA or certificate hierarchy would look in terms of, you know, your enterprise root CA and the different certificate authorities that sort of are now being sort of rolled out in lots of different places. And the problem is there's no visibility, no governance, no centralized control. You don't really know what these things are doing, how they've been configured, you know, what controls and things have been put in place. We can actually go deeper into some of those challenges with some of the sort of services that we've, where this is happening today. So, you know, touched on some of them, visibility, tooling. The policy controls is a big one because you customers that use things like TPP are obviously pretty sort of specific about what policies get set and how they get used across the enterprise in terms of issuing certificates and things, and that sort of ties into governance and compliance and various other things. And the other problem is, a big problem actually, is where they store the private keys. So these services are starting, and quite often the private keys are stored in file systems. They may be stored in the Kubernetes secret store, but fundamentally places that you are unsure of or unknown quantities. So how do we fix that? How do we sort of help solve the problem? We want a combination of, you know, the best of both worlds almost. You know, I think it's pretty clear that we can't have one single PKI sort of serving the requests for millions of certificates across the enterprise. And then we also don't want to have these sort of standalone silos or these unmanaged services that are just sort of popping up all over the place. So about sort of actually more than that now, probably 3 years ago, we sort of embarked on a sort of an experiment within Venafi about sort of creating this sort of concept of a distributed CA. And that, it's now called Firefly, and some of you may have sort of heard about Firefly. At a very high level, it's a lightweight distributed machine identity issuer. You configure Firefly to get everything from that SaaS control plane. And then that control plane can then be configured to connect to whatever enterprise certificate authority you would want to use. Any of the CAs that are supported by our cloud solutions can also be used with it. Architecturally, high level, or the way it gets deployed is, as I said, the little Firefly instances are microservices. It's a containerized, typically it's containerized. It gets deployed really by the developers or the platform engineer. So from an info security perspective, the sort of the remit of the information security teams is what's in the inner circle within the control plane. So you can see they have the ability to manage, they've got the visibility, they can define the configurations and the policies and everything with regards to how this distributed issuing service should behave once it's deployed. And then once that's done, the platform teams, such as Mattias, can actually take ownership of the actual runtime of that container and deploy it pretty much anywhere he likes. So to summarize sort of the functionality or the problem that Firefly solves, okay, it enables now a distributed sub-CA service to run within your enterprise.
That sub-CA, by the way, can run either in memory or in HSM, so you have the choice there.
Yeah, good point. It supports HSMs, so that was a big ask from one of our big financial customers, so we added that. You get the visibility because you see everything that's happening within the control plane. It works really well with Kubernetes, and in fact, as we move on, we'll cover that in a little bit more detail later on. But the bonus really, and it's one to think about, is that it also gives us sort of a better post-quantum readiness position. So if you think about the way we target some of these certificates, they're going to be very short-lived, yeah? So that's the primary use case. We're not particularly going to be targeting applications that need long validity periods with Firefly. Not that it can't do that, but it's really focused on much shorter validity periods. And based on that, the automation and the orchestration that's used to actually request those certificates may be requesting certificates really, really quickly, and actually only needing certificates that need to last for, say, 30 seconds maybe. I mean, more realistically, it might be a day or so, but typically you get that kind of sort of control over how certificates get issued. Yep. So, now things are starting to look a bit better. So now we've got a distributed PKI, okay, and it can be distributed to anywhere that a platform engineer or a developer needs to get a certificate. I the InfoSec or CISO gets the ability, or my team rather, gets the ability to actually manage the Firefly deployments and how and where these sub-CAs are deployed. So we have a sort of fully managed, decentralized PKI now, and we've built all of that on the sort of existing foundations of the existing enterprise CA. So we haven't needed to make any changes to what was already there. It's just purely sort of configuration.
And to add to that one as well, like these sub-CAs, they are being really ephemeral. So as you can see in this example, a sub-CA has a validity of 1 month, which is even lower than like what kind of Google suggests for your leave certificates to move to 90 days. And that's the reason is like we care about protecting that sub-CA, but we don't care about operationally like keeping that sub-CA around for a long time. A lot of Kubernetes pods, for example, only run a few days. And because Firefly is meant to be deployed in cloud-native environments or like in these kind of things, they can be short-lived, and we can throw them away, and we just request a new one whenever we want, as long as we can keep the PKI material very safe, and that's like our main concern in this one. For cloud native, what we've seen come up is like service meshes, and it's become really, really popular. And the reason that this is because we have an explosion of applications. Like this picture that you're seeing on the screen here, this is actually a visual representation of all of the microservices that Monzo, the fintech bank from UK, has. And like it's really a lot of different microservices, and a lot of people wanting to start to orchestrate MTLS between all of these services, not only to encrypt everything, but also to enforce least privilege, to make sure that only the applications that need to talk to each other can talk to each other. That means we need to be able to identify each application or workload, and we need to give it an identity. A lot of the service meshes use PIFI. When I talk to a lot of people, they don't necessarily know that connection, but that doesn't matter. Like, it's just like it gives an identity to each pod. One of the great things of service meshes as well is it doesn't require any application changes. So you can have like a normal HTTP service, and it will become HTTPS with MTLS out of the box thanks to the orchestration that the service mesh provides. And it does this by putting in proxy next to your workload. So on the same kind of C group namespace in Linux, for example, it puts that proxy next to it, and it communicates over a loopback interface, and only the proxy talks to other workloads or receives connection from other workloads. A really popular proxy for service meshes that's being used out of the box is Envoy, which is C++ based. Next to what you normally get for security from a service mesh, a lot of people are also starting to use service meshes for gaining extra observability, gaining like timings of like response times of each individual microservice, error rates, and these kind of things. But you can also manage traffic. What I've seen, for example, being used is traffic being split between different versions of applications. So like, for example, I have a new version of a certain application. I only want to send 2% of my traffic to that new version to be able to blue-green test this. This is possible with a service mesh, as you have like really fine-grained layer 7 controls on their one. Like this is a very high-level introduction to service meshes. There's a lot more to do that. But what, based on personal experience, is a lot of companies start to adopt service meshes because of the MTLS and the security capabilities, and then they extend that further to observability and managing of traffic.
Yeah, so to sort of conclude, now sort of 2024 and onwards, we have a distributed PKI infrastructure, which is centrally managed. It changed back to our existing enterprise certificate authority. It will work and supports pretty much all of the modern use cases. We didn't sort of talk about some of the APIs that Firefly itself exposes, but it has multiple APIs, such as REST, gRPC, GraphQL, and Unix domain sockets. So with Unix domain sockets, you can look to maybe embed it into some of those services and applications that actually may be having homegrown CAs. And in fact, we've got a customer, one of the big US banks, is doing exactly that. They're taking out their sort of homegrown embedded CA in one of their big trading applications, and they're going to embed Firefly into that application as a replacement, so they get to manage it properly. Thank you.